So yesterday we introduced systems of equations, or also known as linear systems, and we learned that it just means that we have more than one line, as you can see in the pictures to the right. So today we're going to talk about how to solve them, not by graphing, but by using substitution. But the key is we're still looking for their intersection point. That's still the solution. So the solution to that picture that you can still see, that system is still 3, 2. And remember, that's an x value and a y value that we need. And today, we're still going to be looking for that intersection just by a different way called substitution. So for the first example, I gave the pictures. We have our two equations are up here. And I graphed them on Desmos. And I can see where the intersection is. It's 1, 5. So what we're going to do here is we're going to solve by substitution. And we want to confirm that the answer is actually 1, 5. So the easiest way to think about substitution is just that we need to replace one of the variables so that we have an equation that only has one variable. Because I have x and y in both, and I can't solve both of them. But if I look at my first equation, I know that y is the same thing as 3x plus 2. That's what equals means. So anywhere I see y, I could write 3x plus 2 instead. So down in this equation where I see y, I could write 3x plus 2 instead of that. And so that's what I'm going to do. I'm going to substitute 3x plus 2 into that y. So I'm going to write x plus 2 times, and instead of y, I'm going to write 3x plus 2. And I'm careful to use parentheses here because I need to multiply 2 by the whole thing. All right, and that all equals 11. So now what I need to do is I need to distribute the 2. Okay, so I'm going to go through that, and that's x plus 6x plus 4, and that equals 11. So I can combine these like terms here. I know x plus 6x, that's 7 x's, so I'm going to do that. Plus 4 equals 11. All right, so to solve here, I'm going to subtract 4 from both sides. So I'll get 7x equals 7. And if I divide by 7 on both sides, I get x is 1. But remember, we're looking for a point, and that point has an x and a y value. So we see so far we have x is 1 and x was 1. So we got that good. That's correct so far. But we need to still confirm that that y value should be 5. So at this point, what I can do is I can substitute my x value of 1 into either of the equations. So if I go up there and I plug that into there or to there, either way I'll see that I should get x is 5. So let's do it into this second equation right here. So instead of x, I'm going to write 1 plus 2y equals 11. So I'll subtract the 1 from both sides, and I get 2y equals 10. And if I divide by 2 on both sides, I get y is 5. And sure enough, that's exactly what we have here. So again, your solution is not just the x or the y value, it's that point, it's the pair. So I need 1, 5. That point is the solution, and we can see that right there. All right, so let's do another example. So this one, I didn't graph it. So we're just going to go through and solve it using substitution. And then you can go on to desmos.com afterwards and plug them in, and you should confirm on the graph that the intersection is the point that we're going to find. Okay? But so anyway, we have a problem here because I don't have anything solved for x or y. You can see up here I have x minus 2y equals negative 6. On the second equation, I have 4x plus 6y equals 4. So neither of them are solved for x or y, so that's not going to be very easy to substitute. So what I'm looking for, though, is either one where the coefficient is 1. And so if I look at this, that's the one I want to solve for, just that x. And the reason is because I won't have to do any division. So right here, if I take this equation, I'm going to solve for x by just adding the 2y to both sides. And what I get, when that cancels out, is x equals 2y minus 6. And so now I have this equation is still the same as the first one, but I just rewrote it so it's solved for x. And the reason that I did that is because now I know that x is the same thing as 2y minus 6, whatever those values are. So anywhere I see an x, I can replace it with 2y minus 6. And so that's what I'm going to do in my second equation. So now when I see this x, I'm going to replace that x with 2y minus 4, 2y minus 6. So let's do that. So I have 4 times 2y minus 6 plus 6y equals 4. So if I distribute this, I get 8y minus 24 plus 6y equals 4. So now I have 8y and 6y that I could combine into 14y. minus 24 equals 4. Add 24 to both sides, and I get 14y equals 28. Divide both sides by 14, and you get y equals 2. Okay, so now we have a y value, but we don't have an x value. So now what we can do is we can take that y value and we can plug it into either equation. We could plug it in right there or right there. And either way, when we plug in that y value, we'll find the matching or corresponding x value for our point that we're looking for. Okay, so let's do that. I'm going to do the first equation. So I'm going to write x minus 2 times 2, because that's our y value that we found, equals negative 6. So x minus 4 equals negative 6. Add 4 to both sides. And I get x equals negative 2. And so now we have an x value and our y value, and so we have our point. So our point is negative 2, comma 2, and that is our solution. Because again, we're looking for the point of intersection. We're looking for the point that's on both of those lines, and that's it, negative 2, 2. So what I encourage you to do now is go to desmos.com, plug those equations in just as you see them, and you should see that they intersect at negative 2, 2. So and then here we have a quick recap of the steps we just did. So the first step was we solved one of the equations for one of the variables. And when possible, we're always looking for a variable that has a coefficient of 1 or negative 1, because that's the easiest, then we don't have to divide the rest of the equation. Step 2, we're going to substitute whatever expression that we got from step 1, we plug into the other equation, and the goal is to eliminate one of the variables, because you can't work with two at the same time. Once we figure out what one of the variables is, we're going to plug that back into one of the original equations, and that'll give us the others. And remember, we're always looking for a point in x, y. We're looking for a point. That's the solution to our linear. So assignment 7.2 is on page 439, 2, 3, 7, 11, 15, 18, 19. And the challenge problems are 21 and 26. Good luck.